and we are live. Hello, and welcome everybody. Although my viewer count is at 0 right now. What do you got? 63. All right, we're up. Hello everybody. Welcome to the WLAN Pi Go launch live stream. Forgive me if I drop in the word webinar here. I'm gonna accidentally say webinar numerous times, but what I mean is live stream. So now all the presenters on the call, we're going to pretend as though we've only just joined. So hey everyone, how's it all going?
Fantastic,
guys.
Hi.
Hey Nick. Hi everyone.
All right, and we do have some chat. So we do have some messages up in the chat. Cool. We can. Yeah, people are reporting that it's up. People can see us. I guess we do need to give a shout out to Shetil, who was the first person to put a comment on the live stream. But I don't know who we can bring in to be the judge and the adjudicator with the 3 crowns scenario of the crowns being assigned to viewers on YouTube. Not sure. Right. Well, look, I think we'll try and get going with the main content here. We're not going to do any kind of pre-live stream banter, but maybe we'll leave that towards the end. If you do have questions and things that pop up into your mind during the presentation, then please throw them in the comments, and we'll do our best to answer some of them at the end of this session if we can. And if not, we may just say, we hear you, thank you so much, but we don't know the answer to that question yet, and we'll come back to you with an answer, either by putting something on the website, because the fact that you've asked it means that it's probably a good question that wasn't clear enough from the material that we've put out so far. All right. Well, let's get going then. Let's go on to some proper introductions. Jerry, I'm gonna ask you to lead this bit.
Yeah. So yeah, here's the kind of intro here to the WLAN Pi Go. We've been teasing this for a little while now, but if you're not familiar with the WLAN Pi project, if this is new to you, this project's been around for quite a number of years. It's a community-driven project, open source software. And yeah, as far as the hardware component, you can see we've gone through quite a few iterations of hardware over the years. And yeah, it's evolved quite a bit as kind of the needs as wireless engineers have changed. The project is kind of adapted, and some of it's just due to hardware availability and things like that as well. But yeah, now we have things like Wi-Fi 7 that we didn't have when the project started. So and things like 6 gigahertz. So yeah, let's talk a little bit about kind of where things are going then, as far as the community side of things or the project side of things. Let's take a look at the team itself. So as far as the team that kind of makes up these tools, the hardware, the software, things like that, we've got the core kind of team. You can see pretty much, yeah, everybody on the core team here is on the call. We also have a few new contributors as well. So these are all the people that really make all this happen, from the hardware to the software. And yeah, just kind of keep driving this project forward and fixing bugs and adding features and all that kind of stuff. And you can see the common theme here is, we're not a bunch of, product folks. We're not a bunch of developers. We're really, for the most part, a bunch of Wi-Fi engineers that see a need for certain tools. And I would say probably at the heart of all this is all of us really appreciate tools to do our jobs. And yeah, if we see a need where, hey, there's a certain tool or certain function or feature that would be really helpful to doing our own jobs, that's what kind of motivates us to building these tools and making them available to the community. But yeah, huge shout out to all these folks, especially if you're using any of the WLAN Pi products, tools. If you've used them at all over the years and they've been helpful to do your job, these are really the folks that have made all that happen. Some of them are just kind of are honorable contributors in the sense that maybe they've contributed at certain points in time or had significant contributions at certain points of the project. And then we have certain folks that are, every week digging into the code, attending developer meetings to keep driving this project forward. So yeah, huge props to these guys. It's been a great ton of fun, working with these guys, meeting with them on a weekly basis to keep figuring out new solutions, new tools, new ways to keep driving this forward.
Cool. Let's talk about the hardware.
Yeah, that's what people want to hear about. So let's talk about the WLAN Pi Go hardware. Nick, what do you got?
I just got one question for you though, Jerry. And we don't need to go into like a history lesson, but like I want to know, like, as the kind of the grandfather of the WLAN Pi project, like how heavy is that? Like, do you feel a heavy weight on your shoulders of you started this P rolling at the beginning of a hill, and it's become pretty big now.
I mean, honestly, it's just I do it for fun. So no, I don't feel a whole lot of weight. So if I didn't have fun doing this kind of stuff and didn't find this to be helpful in my own kind of profession, either whether that's kind of helping me in my own career development side of things and learning new things and digging into things, or just the fact that I kind of enjoy geeking out with this kind of stuff, then maybe I would feel some weight to this project. But yeah, honestly, this is just, fun for me. So yeah, hopefully you guys feel similarly. This is definitely the enjoyable side of things as far as, as much as I enjoy my day job and things like that, like this is a fun thing that I do.
Oh, cool. All right. Thanks.
So I guess over to you, Matt, to actually talk about the WLAN Pi Go hardware. What is it? What it does? How it works?
Awesome. Yeah, so here's the WLAN Pi Go. It's a small, portable, professional-grade tool designed by the team and then assembled by Ossium. Connects directly to your phone, tablet, laptop for on-the-go analysis, anytime, anywhere. So if you look at the bottom left, there's a data port. That's where you connect your USB cable to your phone. No battery, no charger, just plug it in and your host powers the device. So next to that is a status LED, lets you know that the device is up and running. And then above that is the accessory port where you can attach an optional Wi-Fi Lucid. On the bottom, and we'll talk about this more, there is a MagSafe compatible mount, so you can attach it to the back of your phone for those on-the-go measurements. And then on the right, you'll see what's included in the box. You've got the Go, 2 braided USB cables, one Type A and one Type C. And those are nylon braided and come with aluminum connectors on the end, and a zipper box so you can toss it in your backpack or toolkit and it doesn't get all beat up or broken. And then under the hood of the Go, there's a Raspberry Pi CM4 with 1 gigabyte of RAM and 8 gigabytes of flash, and an Intel BE200 Wi-Fi card. So it gives you full tri-band 2.4, 5, 6 gigahertz with the latest support for Wi-Fi 7 in a real compact form factor. And obviously it runs WLAN Pi OS, which is so cool. On the next slide, for those of you who like to geek out about the hardware, I included a picture of the PCB, the carrier board. It's a 4-layer board with high-speed traces for PCIe and USB. There's 66 parts on the board. And on the right, there is an exploded view of the assembly. So you've got the tri-band omnidirectional Wi-Fi antennas on the top. Those were custom designed, tuned, and balanced to deliver performance across all the bands. And those are mounted at 90 degrees so that we get good coverage regardless of the orientation. So below that's the case top. And then we've got the main carrier board, actually the BE200, and then the main carrier board, which is shown on the left. And then under that is the CM4 and then the MagSafe compatible alignment magnets, and those get installed into the aluminum heatsink, which doubles as the case back. We really tried to lay this out, for performance, noise, and reliability. So that's that's the assembly. Let's go to the next slide. We've got the. I wanted to talk a little bit about, this is something you want to carry in your toolbox and use every day, and it needs to be have a professional look and feel, and that's why we really spent time doing a CNC machined case. The top shell in the dock is made from Delrin aluminum, or Delrin. It's like a tough, lightweight, scratch-resistant plastic, easy to machine, looks great. And then the case bottom is a aluminum 6061 T6 anodized black, and it doubles as a heat sink for passive cooling. So there's no fans, no moving parts. And then we finished it off with the laser etching on top, so it's got that clean, professional look. And then, we really chose the CNC machining to avoid doing, custom injection molds. Those are expensive for a limited run tool like this, but it still gives you that rugged feel and high quality feel that you want. So. And then back on the left side of the slide, I want to show you again how to plug it up. You just connect it to your iPhone, and you're ready to analyze anytime, anywhere. So at this point, I want to pass the mic back to Ben, where he can talk about the certification process.
Hold on. I know. I realize I said we'd leave questions to the end, but now I see there's one in here that would be great just to answer right now, because it's poignant to one of the comments you just mentioned. So. Screen.
Got it. Yeah. Lucid and Clarity are both supported. So those are, one's just a little bit faster, the Lucid. So those are fully compatible and plug in. You'll see the two little dots on top of the case. That's so you don't plug in your phone into the dock port. So that was there to make sure that doesn't happen. But yeah, great question.
Beautiful. Thank you.
So, let's talk about the next slide, which is around certification. So,
Ben, I'll pause you for a sec. I saw you teasing the magnetic attachment, so I'll make you full screen.
Oh, right. Yeah, that's a good
10 seconds to do it slowly.
So, one of the main ways we use this, which you could use it in any way you want separated, but one of the really convenient features is you can just snap it to the back of your phone with a little link cable. Okay. Now, because you're doing that, and that's so convenient, you're also going to hold it in your hand. And because of that, we wanted to make sure that there was absolutely no doubt over safety, EMC, or any sort of regulation, because this is something you might hold. You might even take a call. So if we go back to the slides, what we did is we chose to take this product through certification. So you'll all be pleased to know that the WLAN Pi Go is FCC certified, and we've done all of the safety checks. So there's Nick and I in a lab here in the UK. We employed a consultant called Sulis Consultants who helped us with this, and we spent days in the lab taking this through testing, EMC testing. It was zapped with 10,000 volts and all of these things to make sure that it's all great, as was some of the other WLAN Pis as well. But the result of this is, because it now is in your hand, we have absolutely made sure that we can't radiate people too much. And to get through the FCC certification, we've now classified this device as a passive scanning device, right? So, but there is one tool that everybody said, one of these tools, one of these things that would really work well is Profiler. So those of you who are familiar to WLAN Pi will know that Profiler is an amazing way to quickly understand a device in the field and what it's capable of. But to do that, it has to transmit beacons. And there is a specific absorption called SAR, which is about how much radiation goes into people. And we had to stay under some limits. So we actually went and extended the testing that little bit further to ensure that we could broadcast beacons just for the use of Profiler, just to actually get the association response from a device, and at that point then shut down. And actually that's now certified as part of the FCC certification to be under the SAR radiation limits. So to wrap up, this can do everything you need it to do to be a great Wi-Fi analyzer. You can hold it in your hand. You're not going to be radiated, but it will not be a client currently. Maybe that's something for the future. It can be a client in the future. But if enough of you guys are interested and we get, sudden great interest in the product and they fly off the shelves, maybe we'll take that step further. But for now, this is something that will not be a client, but as you're about to see in the next slides, it's got a ton of capability as a passive device.
Hey, Ben, one of the most poignant questions that cropped up there. You mentioned that we went through the FCC testing. Do you hit on this later, or is it comment about the other regulatory domains worth mentioning? Because we also took it through the European.
So we've been through safety testing in all regions. The Intel modem was an FCC certified modem, and it has other certifications. But in order to use it and to retain the FCC certification, we had to do an extension to that. And so that was the main reason we've chosen FCC. Most of our customer base is in the US. Matt, I don't know if you shed any light if we've automatically got European regulation.
The grants are all from the FCC. There was some ETSI testing that we did, and some.
That's right.
I don't remember what we got on if we did 300, 328, or I don't recall off the top of my head. But we had to do that because we did custom antennas too, right? Because those are not default antennas for the Intel module. So that's why we had to run it through. We have a grant. So pretty cool.
Yeah. So the question on the screen there, can it simulate an AP and capture client profiles? Yes, it can, because it broadcasts for such a short time to do that the average power is below the threshold that required us to recertify it. So yes, you can do that. Okay, that's that. I think over to Josh.
Cool. So one of the things we did with the Go is change our partition layout a little bit so that we could do better updates. So for those of you that are familiar with the WLAN Pi, whenever you've done an update, you've pulled out the, you've done this sort of thing where you've pulled out the SD card, you've flashed the SD card. On the Go, there's not an SD card, right? There's an actual, it's an eMMC on the internals. So what we've done from a partition layout perspective is created a couple different boot file systems and root file systems so that we have an A set and a B set, so we can do updates to one or the other, and that allows us to have better failover or fail back if we have a problem updating. And what this has done is enabled us to do updates from the WLAN Pi app, which we'll talk about a little bit in the future. But one of the cool things that this kind of is done, or that we've set up for you guys, is if you use your data in the home directory, it's persistent now. So updates don't wipe your data in the home directory, but if you do end up, getting into the nuts and bolts of it and making some changes in the root file system, that would not be maintained at this time right now. But this is something that we've improved with the WLAN Pi Go, and I hope to bring some of this back to the other platforms too in the future. So that's all I have on this. So back to you, Ben.
I think so. Yeah. Right. So You're going to see a whole bunch of features and tools and everything that you can do with the WLAN Pi, but we mustn't ever forget that a product like this is hard to manage. Just as Josh said, we've got this embedded image. So really there just needs to be an easy way for you guys to be able to get into it, see it, manage it, update it. So we created the WLAN Pi app for that. WLAN Pi app is a cross-platform app. So just for the technical people and the coders on the call, it's been written in Flutter. So everything compiles for iOS and Android. So you can go to search this up on the iOS and Android stores today, and it's there. And you can grab that. And with that, it'll allow you immediately just to connect your WLAN Pi, and it shows up straight away. So a lot of the apps that we're using these days use Bonjour browsing or multicast DNS to find the WLAN Pi. And so you don't have to go searching for it. You don't need to know its IP address. You don't need to know anything. You just plug it in and you'll see its name pop up. And then with that, you can immediately keep your Pi up to date. You can check the health. You can look at its configuration, and you can currently operate Profiler through it. And a few other tools will be coming soon. So actually, we've got a video of it in use. And I'll just talk while this is going. So this is, you press the connect button, and you can see my WLAN Pi Go just pops straight up there, and I press connect. Immediately, I can see what OS version is running. And I can do a check for updates. If there was an update, it would have held there and offered me an opportunity to do that update. I can easily go and scan it and check that its sort of CPU and things are all in good region. And then you can start using apps that are available on it. And for those WLAN Pi users of the other products, you can also see immediately that you can do a lot of the things that were available on the screen of the other units. So being able to see what ports are available, what networks are available, have a look at the summary and so on. So this is just because we've taken away the screen. We gave you an app. Now you can keep it up to date. And this is kind of your sidekick companion, just for ensuring that your Go is always fresh.
Amazing. Thank you, Ben. Just a quick question on the WLAN Pi app. Does it only support the Go, or does it support all the other models like the M4, R4 Pro?
Yeah, so all of the products work with as long as you have their latest images on the WLAN Pi app. You can only update the Go because currently only the Go is using that AB image format. The other products are not, but there is a plan in the works for us to migrate the other products as well. I think all of you will appreciate the persistent home drive that comes with that update. So one day we'll get there. But yes, and in fact, Jiri, is a good question, because when you go to the apps page on the WLAN Pi app, you will see different apps like Kismet and so on showing up on the other products which support that. A lot of those apps have been removed from the Go because we've got limited space and we want to make sure everything's as streamlined as possible.
Excellent. Thank you so much, Ben. So I think with this, we're moving on to Wi-Fi scanning using WLAN Pi Go. So if we move forward here, and I guess today, if we just summarize what we can do today with an iPhone, basically the iPhone has a inbuilt Wi-Fi radio, but we as developers don't get access to it. So we can't really scan, we can't take a bucket capture on the iOS devices simply because there's no access to the radio. So typically the best we can do, as many of you know, is we would use the airport utility. So this is something you can do today. Download the airport utility, start scanning. You get a couple of APs on channel 5, but it doesn't tell you, is it channel 5 in 6 gigahertz band? Is it channel 5 in 2.4 gigahertz, which ideally you should not be using anyway. So what I'm trying to say, the Wi-Fi scanning capability of iOS devices is quite limited, which basically is what we what we are trying to fix with the WLAN Pi Go attached to your phone or even iPad, and running the Wi-Fi Explorer Pi. So yeah, it's my great pleasure to talk about the apps Adrian from Intuitive Bits wrote over the past few months. Adrian is traveling, by the way, but if you have any questions, feel free to ask. He's there to answer any questions you might have. The app, the Wi-Fi Explorer Pi, is in a beta at the minute. You can get it using test flight. We'll share the links with you. But the beauty is this unlocks the full Wi-Fi 7 radio built into the WLAN Pi Go. So you can use the radio of the Go over the USB-C link on your iPhone, which means you can do full Wi-Fi scanning. And when we say full Wi-Fi scanning, you can actually look inside the beacons, see the information elements. You can do 2.4, 5 gig, 6 gig scanning. And you basically get expert visibility into things like channel utilization, all the individual information elements, TX power levels, and so on. So that's Wi-Fi Explorer Pi, ready in your pocket for whenever you are. And what we wanted to do was just to give you a few examples of what you can do with the app. So Wi-Fi scanning is obviously the kind of basic scenario. But if you look towards the top, there's like a spectrum chart. You can see all the 2.4 gigahertz channels, 5 gigahertz, and the blue stands for the DFS channels, plus all the 6 gig channels. So this is just a quick peek. It gives you visibility of what channels is the venue where I am at the minute using. Is the channel plan okay, or are they perhaps using super wide channels and they shouldn't? So there's just a quick peek, but then you can really get all the scan results. You can look in the actual detail. So what I was going to show you is just a quick demo of a high channel utilization example. So this is basically someone with an iPhone, WLAN Pi Go attached to the phone, and the USB-C connection between the two, Wi-Fi Explorer Pi app running on the iPhone. And just with that, you can select the Go as a device you want to use for scanning. And I started a new scan. So at this point, the scan results from the BE200 on the WLAN Pi Go flow into the Wi-Fi Explorer Pi app. You can filter by the SSID. So I'm just looking for my guest SSID here. And I know there might be a problem with channel utilization, perhaps. So I will be looking into channel utilization, and just by using the slider towards the top of the screen, I can say, show me all the BSSIDs that report 60% plus channel utilization. So just by doing that, you can see channel utilization 93% with only 3 clients. So arguably there's someone pushing some heavy traffic. But the beauty is I just need my iPhone plus the Go, which arguably travels with you in your everyday tools bag, and you don't need a kind of laptop or any larger device with you. So when your sales conversation turns into a bit of a troubleshooting exercise, you can basically use the Go to check what is happening, why is it happening, what's going on. That's just one example. The second one we've got for you here is sticky clients. So basically in this scenario, we have a number of APs, but the problem is most of the clients actually stick to a single access point, and we are trying to look into what the problem is. I don't have my laptop on me, so I would use the Go attached to the phone. We'll do a quick scan. We'll look for the SSID we are interested in. So I'm just waiting for the scan results to flow into the app. And in this case, I'm looking for the B6 SSID. And we want to see, basically we have 2 access points here, one outdoor, one indoor. And just by looking at this, you can see that the received signal strength on this AP is significantly higher than on the other AP. But we can look even deeper. So yeah, signal strength is one part. The other part is we can go into the information elements, and this basically gives you visibility into the individual information elements in the beacon. So I can look into that. I can see the transmit power there, and basically compare the client count as well between the APs. So you'll see that on this access point, I have 0 clients, very low channel utilization. That's probably just neighboring APs. But if I look into the TPC report, you can see that the TX power level on this AP was 10 dBm. So we have basically significantly lower transmit power. If you have noticed, the channel width was also different on the AP. So basically, I have 2 APs serving the same SSID, but one is running with 80 megahertz wide channel width. The one with less clients only had 20 megahertz wide channel width, which arguably is the right setting depending on the scenario. But yeah, that's basically one of the reasons. It just contributes to it. Typically, clients would prefer wider channel. So that's another example. And just to give you a couple more, and we have a few more demos for you. So this is my personal favorite. Kudos to Adrian again for developing this in a super short period of time. So AP Finder or Find My AP scenario is basically you might be beeping in the background. So that's part of the app. Basically, you can use the app to locate an access point. So yeah, typically if you walk into a building, you don't see any AP. The AP might perhaps be above the ceiling, or it might be inside a wall or any other location which you can't see. You can basically use the AP Finder, and this is how it looks from the app, just to show you a nice clean view of the actual UI. So I'll basically start just a new scan. We start looking for our SSID. So in this case, I just created an extra SSID, assigned the SSID to the AP I'm looking for, and now I'm just going to filter for the AP we are after. Select the AP, and toward the top right-hand corner as an icon for the AP Finder. So I hit the button, and you can see that I'm arguably quite far from the access point at this point. And basically, the faster the beep, I guess it's quite intuitive anyway. So the more intense the beep is, the closer you are to the AP. But the beauty is we log onto a single channel, so we get super fast scan results. You can see that the RSSI updates very, very often. I'll speed things up a bit. So you can see that I kind of took the wrong path. I'm walking away from this AP. And eventually, I think I might have figured out where the AP actually is. So I'm walking towards it. And basically, when you find the AP, what you can do is you can screenshot this. That gives you the BSSID, the AP name, the channel it was on. You can switch to your camera app. You can take a photo where the AP actually was when you found it, and perhaps you can share it with your installation / deinstallation team, and they can go and pretty much remove the AP or upgrade the AP from the legacy AP to a new one. So yeah, that's the AP Finder. Again, very well done, Adrian. I'll pause here. Nick or anyone, any questions I think we wanted to answer now?
Yeah, I think there were some pretty important ones. I guess maybe take this one. Just quick point of clarity.
Yeah, very good question. So we should say as Ben mentioned, the WLAN Pi app, the official WLAN Pi app, works on Android and iOS. The Wi-Fi Explorer Pi, which you have just seen, so the AP Finder, Wi-Fi scanning, packet capture, that works on iOS today. So that's iPad, iPhone.
And I guess I'll take this one. Just talking about tablets. Yeah, for like this, for Adrian's Wi-Fi Explorer Pi app, it needs to be an iPhone or an iPad with a USB-C cable, with a USB-C port. I'll talk about the janky hack to make it work with Lightning devices on another time. It's horrible. We can make it work, but it's It's truly horrible. So essentially, no, it needs to be USB-C iPhone or iPad. But then, like, how do we hang the Go on the where do you put the WLAN Pi Go? And I have some ideas for accessories that I'm toying with about how we could basically enable a Go to attach to the back of a tablet. But we don't need to go into great detail on that one right now. We did have this one, which was good for a point of clarity as well. How does the WLAN Pi talk? How does the WLAN Pi Go talk to the iPhone? And that's a good point to re-clarify, and that is it's via the USB cable that provides power and data from your host device to the WLAN Pi Go.
There you go.
Beautiful. Okay, think that's good for now.
Brilliant. Thank you, Nick. So I have a couple more demos before I hand it to back to the team. So what we wanted to show you was the visibility into the information elements inside the beacon frames. So yeah, I can obviously scan, but I can look into the detail if I want to look at the raw data inside the beacon. I can also do it from the iPhone. So if we pick one of the BSSIDs here, we'll go into this one, for example. You can see all the detail. What standard does this AP support? So this is Wi-Fi 6 AP. You can see all the amendments it supports and the features it's got enabled. I should say some of these information elements we parse and show you on the preview screen. So the channel utilization, number of clients, if the AP reports it, you will see it there. But then you can drill deeper into the information element section, and you can choose the part you're interested in. So you can see the TX power here, for example, just to understand what is the TX power balance between the APs, and do clients have pretty much equal chance joining to one AP or the other AP. You can see reduced neighbor report, which basically tells me using the 5 gigahertz beacon, that is a 6 gigahertz capable radio on channel 53, for example. So yeah, all that is available to you. The app is available on test flight, so you can basically sign up, download it. Assuming you have a Go, you can go and use it. Now switching gears to packet capture. So we mentioned that packet capture is not really available on iPhones, iPads, or has not been. But what you can do is you can attach WLAN Pi Go to the phone, download the AirTool Pi app, which also works with all the other Pis, by the way. And you can start a packet capture. So from there, you can basically send the PCAP to someone or airdrop it to yourself and do a proper analysis on a big screen. But with AirTool Pi, what you can do is, I think we have an example here. Similar UI to the Wi-Fi Explorer Pi. I select the Go, I choose my channel. So I'm going to select the band and go to 6 gigahertz, PSC channel 53. I think this was 160 megahertz wide, just because I could. There's no other Wi-Fi around me at that point. And I took a 10-15 second PCAP. You can see that there's quite some traffic on the air. So it's going to be a couple of hundred megs. And directly from the app, I can go select this PCAP. I can see the date and time, which is quite useful as well as the channel from the app. And I can go and airdrop it to me. So I'm just selecting my Mac, and it's on its way to the Mac. Going fast forward, it will basically appear as a PCAP file on your laptop, which takes me to this demo, just to close things off. So now I have a PCAP on my Mac. I can open it in Wireshark on a big screen. Obviously, I can look into it. I just selected a random beacon. You can see all the detail you would see in the in the app. You can see it in Wireshark. But in this example, what I was going to show you was just a IO graphs feature, and I'm comparing the total number of data frames to retransmitted frames, just to suggest what is the retry rate on this for this particular client on this particular radio. So just an example of what you can do with Wireshark. But basically, you have a full 6 gigahertz peak up, which you can go and analyze. So that is the AirTool Pi on an iPhone or iPad. And I think at this point, I'll hand it over to you, Jerry.
Thanks, Jerry. Yeah, happy to talk about the Humina Onsite integration as well. So hopefully by now you've kind of picked up on the theme here with the Go is it's all about the apps, right? So in the past, with all the previous kind of WLAN Pi solutions, hardware kind of software solutions, it was more browser-based, cloud-based, or not browser-based slash, like SSH, more CLI-based. But now with the Go, being attached to a mobile device like an iOS device or an Android device, the apps are really where a lot of the value comes in and the usefulness comes in. I'm going to try something a little bit differently here. So I did do a survey recently with the Go. Let me see if I can get my screen share working here. We'll try and do something a little more adventurous here of, let's see if I do this and share. Are you able to bring that up, Jerry, and show my my screen share? Cool. We did not rehearse this, so what could go wrong. But yeah, I remembered that I actually did do a site survey when we were initially doing some testing. I was actually at a WLPC conference. This one was actually in WLPC Mexico. If anybody from Mexico is on the stream, that was an awesome event. But yeah, was kind of secretly doing some initial testing with one of the first WLAN Pi Go prototypes, and yeah, was able to capture some site survey data, and yeah, I really started to connect the dots, at least for me, of some of the usefulness of this really ultra portable scanner measurement device, and yeah, being able to see this of like, okay, yeah, I can actually do things like a site survey. Just like we can with other hardware, but in this extremely portable kind of setup, right? Now, yeah, it does require you to walk a little bit slower, things like that. But the convenience is really the big value here, right? And you can kind of see my walking paths here. We can see we don't have any coverage out in this area here. We're measuring down to like the -80s here, so it can measure to very low signal strengths. I'm seeing all the way down to like -85 out here, kind of on the edge. So yeah, you can get some really -89 even over here. But yeah, get all the details like you would normally during a site survey. The channel width, even Wi-Fi generation, transmit power, SSIDs, all the stuff that we would normally get. However, what I think is really cool about this, and I saw some comments in chat about measuring things like attenuation and stuff, that already all works, right? If you have Humina Onsite and you're using like Humina Onsite, now that I've got all this data in this project here, I can jump over to the simulation side, take that data that was captured during my site survey with the Go, and I can actually simulate now adding access points. I don't need to, draw walls and objects. It's learned about this environment. And if you notice on my site survey, one of the things that I did was I actually walked outside. This is actually out in like kind of the driveway parking lot area here. So I actually even got the exterior kind of attenuation of the building to understand how that exterior, there's a lot of glass and stone and things like that, how that's going to attenuate the signal. So now I can actually, do my design, maybe redesign this network using that data that I collected during that site survey, and it actually learned the environment. So what we're doing in Humina, for those of you that are Humina users, we have this learned environment. So when you do take that survey data, put that into your project, you can see all this in here and easily kind of simulate a new design using that. So yeah, a lot of value you can get out of that. But yeah, this works for anybody that's using Humina Onsite, and you just connect your WLAN Pi Go, and it'll connect to that and use that radio as your measurement device. I'll turn it back over to you, Jerry.
Excellent. Thank you so much, Jerry. I guess, Matt, if you are ready, we can hand it back to you for the MetaGeek part. So let me reshare. Did you want to say anything to introduce it, just to kind of set the expectation what it is, what platforms it supports?
So there was a question earlier about, hey, what can I plug my Go into? But it also plugs into a Mac and a PC. So the MetaGeek app is PC only, and we've got a little demo showing kind of how to hook multiple Goes up to a laptop. I think it might be interesting for some of you. So yeah, just play the video, and I think it's narrated, so I don't need to say anything here.
Excellent, thank you.
Hey guys, Casey from Ossium here. Just want to show you some of the latest features in the MetaGeek app now that it supports the WLAN Pi Go. And it doesn't support just one. It supports up to 3 WLAN Pi Go's simultaneously. This means you can now capture packets on up to 3 channels at once. This is a big deal, especially for troubleshooting roaming and band steering issues where you don't want to miss a single packet. So here's my current setup. I've got a laptop with 3 Go's connected in my living room, and I'll be walking from one access point to another with an iPhone in hand, hoping to catch a roaming event. These are all the radios under my Cathy-fied network. You can see they're operating on multiple channels across the 2.4, 5, and 6 gigahertz bands. This gives you a chance to see how automatic adapter management works in the MetaGeek app. The WLAN Pi Go's are now only sweeping channels that these radios are using, which is pretty neat. Now, as I walk toward the access point, keep an eye on the events column. This will show any roaming, band steering, or other association events in real time. Because we've got 3 Go's sweeping the relevant channels, we increase our chances of catching every packet involved in those transitions. And there it is, an association and some roaming events. From here, we can click on the radio to see the connected clients. This one here with all the events is clearly my iPhone. Now we can drill down into the client view and start seeing detailed info, airtime distribution, client capabilities, and more. You can also track the client using the signal strength over time graph, which helps identify problematic devices or top talkers on your network. Of course, you can also scroll through the client timeline to see which radio it roamed to, or if it's stuck on the wrong one. But if you need to troubleshoot deeper in another tool like Wireshark or IPA, you can actually send the PCAP data already filtered down to this specific conversation between the access point and client. This way you're not digging through noise or building filters. It's already done for you with just a few clicks. Obviously, there's a lot more I can't get to, but I'm really excited about what's possible with the WLAN Pi Go and where we're headed next. Thanks, guys.
Excellent. Thank you. Thank you, Matt.
Hey, guys.
Thank you, Matt and Casey. And yeah, I guess on the Spectrum front, again, Matt, if you wanted to say a couple of words, over to you.
Yeah, so I mean, this is like a sneak peek. It's not released yet, so the goal here is to show you that, hey, we've got the port there on the WLAN Pi Go. It will work with it. It's just not finished yet, and I think it'll probably also get integrated into some of the other apps, so you'll get Spectrum that way.
Good. So this is basically an iOS device with the Go attached to it and the Lucid spectrum analyzer plugged into the Pi, which basically gives you Wi-Fi scanning, Wi-Fi 7 radio plus spectrum analysis. I'll play the video.
Here's a sneak peek of something new we're working on. We're working on a pocket-sized, touch-optimized version of Channelizer, powered by Wi-Spy Lucid and WLAN Pi Go. Channelizer has been revealing invisible Wi-Fi and RF with innovative visualizations for over a decade. The density view shows how RF patterns repeat over time, showing not only which frequencies are most used, but providing a visual fingerprint that can help identify the source of transmissions. The inspector provides detailed information about the signal characteristics at each frequency. Access points are indicated with Wi-Fi overlays we've called ziggurats since we introduced them in Insider back in 2007. The waterfall view is a top-down representation of the density view and reveals how frequency usage changes over time. The same time frame is represented in both the density and waterfall views, as well as the ziggurats, providing a complete, unified picture of the wireless environment. And here we demonstrate how these three perspectives come together to show a heavily used Wi-Fi network on 5 gigahertz and a potential source of interference occurring in the 2.4 gigahertz band. Obviously, there's lots more that we didn't have a chance to build yet, but we are moving fast, so stay tuned.
Alrighty. Okay.
Here's a sneak.
So I think that's it, right? From a kind of presented content standpoint, I think we should jump into we can close things out by just saying, please jump over to the WLANPi.com website. But should we do the Q&A now? We've got some racked up some questions. Unless there's any.
I was going to say,
right.
Nick, before you find a good question, I was going to say pretty much any of us here on this call, all the speakers, we tend to carry a Lucid and a WLAN Pi Go on us. So if you spot us at an event or you bump into us, feel free to have a go and ask if you're interested in seeing it. I mean, with the Go, really, I find myself just walking down the street whenever I walk somewhere, checking what's the closest AP, what the settings are, or if you happen to walk into a meeting, have this in your tools bag is just super, super nice because you don't really need to be ready for a troubleshooting exercise. You can basically just walk into a meeting and show your customer, look, this is how you've configured things and this is how you could improve it. So yeah, if you're interested, I think this is really the best way to kind of experience it firsthand. Anyway, back to you, Nick. Any good questions we want to answer?
Yeah, I think maybe the final call to action thing is just where do you get hold of one? If you go to the WLAN Pi website and click on purchase, there's a link on the WLAN Pi website that'll take you to the Big Quam store, which is going to serve the US, and badgerwifi.co.uk website, which will serve globally. As Ossium are manufacturing these, you can also buy them from there. You can also buy them from Ossium direct. Obviously, I mean, Badger Wi-Fi and Big Crown would like it if you buy it from us. But there is contribution back to the project, kind of regardless of which route you take. Then, if we go into let's bring up some questions, and maybe we can just all take these as we wish. But I thought this was a good one here, probably for Matt.
Great question. So the USB it negotiates a USB power delivery contract, max of 900 milliamps at 5 volts. So and pretty much all of the iPhones are capable of supplying that. So I think during an actual scan, it's probably like 700 milliamps, somewhere in that range. So it doesn't use the full 900, but if you're using everything, you can get a little high. Actually, 600, I think, is what it was for a Wi-Fi scan. So it'll impact battery life, but not a significant amount.
I'm doing a scan right now. I've got a little amp meter connected on this USB cable, and it's showing 1.4 watts of power draw, and that's it while it's scanning. So that's the radio actually up and listening and decoding and all that kind of stuff. So yeah, about roughly 1.5 watts, you could say, of power draw to power the adapter, the guts of it and everything.
And I'll jump in here and say, although you can take a Lightning iPhone, maybe there are some people out there who like to use a phone that's appropriately sized for their hand. But unfortunately, even if you use the the Apple camera adapter, and then you get a USB-A port, and then you try and plug that into your WLAN Pi Go, the phone will provide enough. Well, it will provide power to the WLAN Pi Go, and you'll see the LED come on, but it's not enough for the Go to boot. So it's a pretty dissatisfying experience if you try to use a non-USB Type-C iOS device to power up the Go. And I don't know whether, maybe for development purposes, there might be a scenario out there where the USB power injection harness might be attractive. I'm very happy to whip up a housing for the chip. We have a small PCB that injects power, and that does allow you to plug a Go into a Lightning iOS device, and then you have to provide power from somewhere else. And I thought this was a great idea at the beginning of our development process for this, and I was all excited about it. And then I tried using it probably once on site, and was like, nope, I'm out. Cannot be dealing with this. Too many cables.
This is the reason why I stay with this project and come to the meetings, is to see what clever thing Nick has created in between 1 week to the next. He's always coming up with some creative solutions, we'll say.
It just turns into a spaghetti mess of cables, and it was horrible. So I do not recommend. Do not recommend.
And you guys can hear me well?
We can hear you.
Yep.
Yeah, man.
All right. Yeah, just wanted to apologize. I'm on the road, so it was hard for me to participate. But I want to thank Jerry for the great demos and explanations. Just to add, the Go also works with Wi-Fi Explorer Pro on the Mac, and with AirTool on the Mac too. So you can just plug it, and it can be used as a regular WLAN Pi. It actually detects the Go, so it shows up as a separate device, but it works the same. And yeah, I mean, I'm very excited. It's a pretty nice WLAN Pi, the best we have ever made. So I hope you guys like it, and any questions, feel free to shoot me a message, and I'll be happy to help with anything.
Well, I think it's appropriate here to say, well, thank you, Adrian, for making Wi-Fi Explorer Pi. That's pretty pivotal in my excitement. Not like excitement about the Go, but like that was like one of the core things for me that I was really excited to see in the absence of trying to get that information out of the phone itself.
Could I just jump in here, because I see some questions about how do people get Wi-Fi Explorer Pi, because it's not yet released fully on the stores. It's in public beta, and there is a link. One of your easiest ways, though, might be to download the WLAN Pi app, which you can find on the store, and in there is a partner app set of links, so you can then find the WLAN Pi app and click on it from there, and as you can AirTool, and you can then download them from there.
Yes, and also to add that it works with any WLAN Pi, not only the Go, but some of the functions are exclusive to the Go. So like the IP Finder function that's exclusive to the Go, as it's the one you will have there. You can move with it. All the others being stationary doesn't make much sense. But yeah.
Thank you, Ben. So I don't want to go on too much longer than an hour. There's maybe a few more questions in here. I think this is kind of like got a really good shape to it. So thank you everybody for the questions, and thank you presenters. I thought this was a pretty good clarifying question. I don't know who's best to, maybe Josh, do you want to take this one?
Yeah, sure. So there's a couple options. The traditional option that we're all used to is Wi-Fi dump. And that works the same way. You connect the Go to your your Mac, your Windows PC, whatever, and you can just put in the IP information and username and password and set up the capture details as you would. Now, Osiem has made their own plugin that does something very similar, which will discover the Go and allow you to set up capture parameters as well. And you can get that from MetaGeek's website. Now, you could also do a straight like TCP dump if you wanted to go hardcore as well.
And that's a free tool. We don't charge for that. It's on our website.
Grand. So I think we've answered. I'll just zip through these final few questions. But how do you get an invite to the test flight of the app? Download the WLAN Pi app. In there, you'll find a link to Adrian's website, and on there you can get access to the test flight. And at some point, that will not be required. Are we going to bring units to WLPC Europe? Yes. Yes. It is our intention to make WLAN Pi Go units available for sale at WLPC, and we will also be using these in the WLAN Pi deep dive at WLPC. Yeah, this is a good question. Maybe, yeah. Matt, do you want to take that one?
Yeah. So the additional USB adapter port, the accessory port, is a bit limited. So and there's a power constraint too. So no, you can't really capture simultaneously on two channels. So you can use two Go's to capture on one, but not on the same Go.
Cool. Thank you. Oh, and this is a nice. Let's have this nice softball question for sort of things to wrap up on. Who hasn't said too much? Jerry, you want to take that? Actually, no, it wasn't Jerry. You made the Matrix, and you tell us the story about you going to Apple.
Yeah, happy to. So apparently, the best way to test compatibility with iOS devices is to walk into an Apple store and ask for permission to plug a WLAN Pi Go into an iPhone or iPad.
Every single device on display.
So, I plug this random black box into all of your hardware.
So yeah, that was actually quite useful. Obviously, we test devices for compatibility. So if I just quickly reshare my screen just to show you where this lives, we compiled a list of supported devices. So if you go to the userguide.wlanpi.com, WLAN Pi Go, we have an FAQ. But we also have a list of supported devices. So it's not exhaustive, but basically the devices we have successfully tested, they can power the Go, they can communicate with the Go, no problem.
Wait.
We have Edit.
Wait a minute. This is live. But what iPhone 13 Pro Max? That can't power the Go, can it? Can it?
Pro Max. I think that must be a typo.
Yeah.
I think this might be a typo. As far as I can tell, I think this is probably 15 Pro Max.
Okay.
Yeah, I think that's a 15. Well spotted. I'll go and edit straight away.
What would have been better? What would have been better would be finding it before we present it on. So yeah, it's a good spot, Nick.
There we go.
But, you could have checked this before the webinar. That live stream, that would have been great.
So yeah, basically a list of devices we have successfully tested, and yeah, as Nick mentioned, iPhone 15 really was the first one that introduced USB-C. So pretty much all the USB-C iPhones, all the USB-C iPads, or most of them we have tested really. We've tested a few Pixel devices. As we were testing, we also managed to find a couple that were not compatible. So that might be worth reviewing. But yeah, as we say, this is not exhaustive list. This is basically the devices we have managed to test and we've had available to us. So if you have a go and you have successfully tested it with another device, just let us know. We will add it to the list.
Yeah, I think the simplest thing on the iOS side of things is if it has a USB-C port, it should work.
Exactly. We've also tested the iOS 26 beta, so from software perspective, it looks all good. So yes, as far as it has a USB-C connector, it should be all good. And then obviously you can have all the apps you can install. Adrian mentioned the just a minute on this. Adrian mentioned the laptops and Wi-Fi Explorer Pro. So if you have Wi-Fi Explorer Pro running on a laptop, you can natively select WLAN Pi Go, connect the Go to your laptop, select the Go, and basically this is the actual Intel BE200 inside the WLAN Pi Go, providing scan results to your Mac, which perhaps might not even be 6 gigahertz capable. You can get 6 gigahertz scan results on that Mac. So really useful, and I can basically do all the other clever stuff. I can select the beacon and look into the actual detail, as you all know.
Maybe this is just because I want to repeat the line about the genesis of the WLAN Pi, but I think this is maybe a nice kind of top point to wrap things up on. But I think the genesis of the WLAN Pi Go was, Jury, that idea, wasn't it, of really what you wanted was the ability to put a Wi-Fi 7 NIC at the end of a USB cable and use it for scanning.
Exactly. I know many of you have explored how do I take a Intel B200 and connect it via USB-C to a Mac or connect it to my laptop. So that's basically how the Go started. Intel B200 with a USB-C connector, which I can plug to my laptop. Obviously, it doesn't do PCIe Express over USB. It behaves like an external sensor. So we do Ethernet over USB between the laptop and the Go, or between the phone and the Go over the USB-C cable, and that's how we get the actual scan results, the spectrum data, and even the packet capture.
It's a USB adapter with a full Linux stack. USB Wi-Fi adapter with a full Linux stack.
Yes, that's a good point. Actually, you can technically SSH to the WLAN Pi Go if you wanted to. You can help us kind of add features, expand the API capabilities, or leverage the existing API on the Go, and basically take the raw scan results and do something with it, with whatever makes sense to your customer or your project. So yeah, that's the beauty. Really, it's open source, available to you. 6 gigahertz capable, Wi-Fi 7, and if you add the spectrum analyzer, you get spectrum as well.
And then maybe there's one more comment just about kind of how does product like WLAN Pi model positioning, and I'll jump in and just say on there, I think we all view the Go joining our lineup of models, which are currently the R4, which is built on top of the Raspberry Pi 4, which you can put together yourself very easily. Then there's the M4 Plus. So those units are the ones that have an Ethernet port, and you probably wouldn't want to try and carry around with you. And then the Go joins this lineup. So I don't think there's any kind of hierarchy here of which. Well, obviously, the youngest one is very special to us all. But like the best WLAN Pi is, well, what do you want to do with it? Like if you want to leave it somewhere, well, probably an M4 Plus is ideal because it's got PoE in it. If you want to like put it somewhere and forget it. But if you want to walk around and discreetly sniff out the Wi-Fi and see what's happening in the airwaves, then it's the Go.
Yeah,
Nick,
so going forward, it'll be what R4, M4 Plus, and the Go. So will be the kind of ongoing hardware, continued hardware. So the Go doesn't phase out any of these other ones. This will be in addition to the M4 Plus and the R4 that have already been available for quite a while now.
And people may be asking, like, well, what about Raspberry Pi 5? And we are aware that the Raspberry Pi 5 exists and the CM5. But at the moment, right now, there's not too much attracting us to the Raspberry Pi 5 line. Just they cost more, they take more power, and they run hotter. And that's fine if we're getting something kick-ass in return. But we're not sure what that is yet. We haven't found out that yet. So at the moment, we will support Raspberry Pi 5s in the future. At the moment, we don't. Our image doesn't work on Raspberry Pi 5s, but in the future it will. And by all means, there may well be an R5 in the future, or an M5 model. We're not sure. Remember, we're a group of Wi-Fi enthusiasts who meet weekly, and sometimes cool things happen.
I like it. It's a good official tagline there.
Nick,
Sometimes cool things happen.
Maybe to round it up, what's the best way for people to keep in touch and stay with their ear to the ground on software updates and hardware updates?
Yes, I think the best way to stay in touch is join our mailing list. Is that where you were? That's where you were teeing up for me. We have sent out more mail shots in the past week than we have in the past 5 years, and that's 2. So don't feel like you're going to be spammed by the WLAN Pi mailing list. If you're lucky, you might get another emailer out of us this year. We'll see. But we are very conscious that we don't want to fill your inbox up with.
And people are asking about updates to the other products, so they work with the app and stuff like that. So that's the kind of thing that we might then be able to inform you of via the mailer.
Absolutely. And other updates will come from Wi-Fi community events, such as the presentation at WLPC, WICO. Are there any others? Nothing that springs to mind. But check out and maybe the WLAN Pi YouTube account. We did put out a few videos several years ago. Maybe we should put out some more at some point in the future. Fantastic. Thank you very much, everybody, for attending. It's been a pleasure.
Yeah, thanks everybody. Thanks everybody for the hard work on the team, and thanks everybody for joining to hear about all the work these guys have done over the last year plus that we've been working on this.
Spectacular. I'm gonna pull the plug. Thanks very much, everybody. Take care. Bye bye.
See you, everyone. Bye.
Thanks. Bye.
Bye.